Okay, if they want to be particularly evil to you, they'll give you a distribution where you don't know the mean or the standard deviation, and you end up setting up a set of simultaneous equations to solve. But they're generally straightforward simultaneous equations. So I've got a random variable x with a mu that I don't know and a standard deviation that I don't know. But it's telling me that x greater than 35 has got a probability of 0.25. So if I map that onto the standard normal distribution, and work out the value of a, but remember what I'm going to end up with is minus a. So menu 7, inverse normal, area 0.025, so that's 1.96, which means a is 1.96. So using the transformation function then, I've got z, which is 1.96, equals x, which is 35, minus mu over the standard deviation. So rearranging that, bringing the standard deviation up, bringing the mu over, it forms one equation with two unknowns. So if I store that, if I call that equation A rather than 1, and if I store that in 1, so if I store that in x, I have to remember it's negative and I need to make it positive. So go into arithmetic, and if I do minus x store a, then in a I've got the positive 1.96. So then I need to take the second set of information, which is on the distribution that I want to work with. The probability of x being less than 15 is 0.1469. So if I transform that onto my standard normal distribution, I want that value of a, which this time will map directly. So back into my standard deviation, 7, inverse normal, 0.1469. I get that a is minus 1.05 when you round that, so that's 1.05, and this time that's going to remain negative, so I'll come back to it in a minute, but let's put it into our transformation function. Minus 1.05 equals 15 minus mu over the standard deviation. So rearranging that, bringing the standard deviation up, bringing the negative mu over, equals 15, and let's call that b. So if I store that now in b, store b, go back into arithmetic. So I've got these two equations, there and there. They've both got positive mu. So if I just subtract A take away B, then the mu's will go. That side becomes 35 minus 15, which equals 20. And on my calculator, all I need to do is A minus B to take those away because of the way that I've stored them. So alpha A take away alpha B means that my sigma is going to be 3. So the standard deviation is 20 divided by 3, or on my calculator, 20 divided by ants, 6.64. And then if I put that in A, I get 1.96 times 6.64 plus mu equals 35. So mu is going to be 35 less 1.96 previous answer, 21.98. So that's about as evil as they can get with that sort of question, where you're having to work out two different unknown variables.